Assalamualaikum and a very good morning to all panels. My name is Nur Ain Arina binti Johan, metric number EN 180240. I am a degree student under the supervision of TS Dr. Azrin Hani bin Abdul Rashid. So today I would like to present to all of you my degree project proposal entitled Obtaining Treatment on Bamboo Fiber for Yarn Spinnability Potential. These are the outline for my presentation today. First, for the background study, nowadays, the textile industry have been considered as the necessary part of human life. There are two types of textile industry that may be shared between the natural fiber and the man-made fiber, which is mostly known as the synthetic fiber. Synthetic fiber has been widely used in the production of textile apparel for the last few decades. However, this synthetic fiber also pose a serious threat to the ecological balance. The textile engineering has recently taken alternative to the plant-based fiber as the substitute for this petrochemical-based synthetic fiber. Bamboo is a sustainable choice for potential material industry due to its similarity mechanical properties to those synthetic fiber. At present, there are just a small number of manufacturing plants in China that process a bamboo fiber into the basic raw material for the natural bamboo yarn manufacture. There are three types of bamboo fabric, which is first natural bamboo, conventional rayon made from bamboo, and the lyocell processed rayon made from bamboo. The regenerated cellulose fibers such as tensile lyocell, modal rayon, and viscose rayon and the bamboo rayon are usually considered as the most significant fibers in terms of the textile and the environment. The rayon is produced from the cellulose pulp of trees, which is a renewable resource, but the fiber spinning phase requires a chemical-intensive process which is more harmful to the environment than polyester and many other synthetic. Next, the viscose process is predominant used to create fiber from bamboo, but the properties of natural bamboo fibers in such bamboo viscose product might have been lost. So, a big consideration must be given to the natural bamboo fiber and properties to generate the final fiber for the yarn spinnability potential of natural bamboo material. This research study has subjected to three different problem statements. First, the more modern technology have posed to the threat to ecosystem and the human health. Second, the technological advancements has resulted in a problem such as contaminations of the environment, air and water, thinning of the ozone layer, and decrease of the grain areas. The third one is synthetic clothing has led to the cause of microplastic pollutions in the oceans. As for example, for the ecosystem threat is cotton productions. Cotton productions is the world's largest consumer of pesticide with 43 million tons of pesticides fuel dust thrown into the air every year. However, natural fiber have been discovered that it has many advantages offer. But there are only a few reports on the natural fiber. Thus, this research is intended to lowering the pollutions by utilizing sustainable fiber and enlarge the studies of natural bamboo fiber properties. It is expected that this study to provide a comprehensive evaluation of bamboo fiber physical and tensile strength performance. For the research objective, this research objective is to generate the experimental research information on the physical properties of the alkaline-treated bamboo fiber with different weight percentage and to analyze the tensile strength of the alkaline-treated bamboo fiber. The scope of study will cover four aspects, which is material, treatment, testing, and analysis. All these aspects will be explained more detail in methodology part. The significance of the study will be divided to three parts, which is toward education, towards the society, and towards environment. For toward education, this study will uncover critical areas in the educational process that many researchers have not been explored. So this discovery of the natural bamboo fiber as the potential textile fabric may aid other researchers in the development of more scientific publications. For towards society, as the bamboo fiber is abundant in Malaysia, the employment opportunities could be provided to the farmers who manage the bamboo plant, which can improve the people's living conditions indirectly. It also can increase the profit by exporting commodities to the other countries. For the environment, the bamboo fiber is such an easy plant to grow organically. Pesticide and fertilizer are rarely used for this bamboo plant. It is a drought tolerant, which it does not require much water for the irrigations. Bamboo fiber also could reduce the use of the synthetic fiber that have posed a serious threat to the ecological balance. These are some of the literature reviews that have been written in the proposal report. As we can see, this is the properties of natural fiber, including the bamboo fiber. The strength of the natural fiber composite depends not only on the interfacial strength but also on the basic strength of the fiber itself. As we can see, fiber has the excellent strength properties, especially the tensile strength. Fiber also has a lesser tensile strength than knaf, rami, and flax, and many others. Therefore, bamboo has the potential to become an important material in the future due to its rapid growth and outstanding fundamental qualities. There have been some research from Okubo 2005, which is he studied the mechanical properties of the bamboo fiber and concluded that the strength of the bamboo fiber was equivalent to the glass fiber. As this study aims to focus on the effect of alkalizations on natural fiber and its medical properties enhancement, we will focus on the chemical treatment adopted for the natural fibers. As you can see in the slide, there are few common modifications that have been explained in the table. The alkaline treatment leads to the increase of the amount of the amorphous cellulose at the expense of crystalline cellulose. If we're focusing on the bamboo fiber by Chen L. 2018, he has commented that with the increasing alkaline concentrations at higher level, the surface of individual bamboo will become more flaky and grooved, and the higher concentrations will also compromise the thermal stability. Some other research of bamboo fiber by Tong L. 2018 also says that the tensile strength and the modulus of the alkaline treated fiber were improved by 45.6 and 72% respectively compared to the untreated fiber. Therefore, the sodium hydroxide treatment have resulted in a higher amount of swelling. We can say that sodium hydroxide can cause a complete lattice transformations from the cellulose to the cellulose 2, in contrast to the other alkali that produce only partial lattice transformations. Next, these are the flowcharts for the methodology of this research. I have divided the flowcharts into three parts, which is the bamboo fiber preparations, bamboo fiber alkali treatments, and the testing analysis. For bamboo fiber preparations, we need to carry out this process because in order to produce the bamboo fiber. Second one is bamboo fiber alkali treatments. This process needs to be carried out in order to achieve the objective one of this research. And lastly, the testing and analysis process needs to be carried out in order to find out the properties of the alkaline treated bamboo fiber. Next, these are the explanations of bamboo fiber preparations. We will use the untreated bamboo fiber as a control sample. The picture below is the process from bamboo comb to fiber. So first, bamboo comb will be water wetting for 1 week. After that, it will go to the stripping, which is the bamboo was cut into a length of 50 cm. It will randomly selected from basal, middle, and the top. Next, it will go to the decorticating, which is the bamboo comb will be mechanically extracted in the decorticator. After we extract the bamboo comb, it will produce a bamboo fiber. However, the bamboo fiber is not very fine. Therefore, we need to use the hand comb using the hacking tool in order to make the bamboo fiber more separated. Okay, the last picture shows the comb of bamboo fiber. For the fiber treatment, we will use the sodium hydroxide as shown in the picture. The alkaline solution's concentrations was prepared using weight per volume percentage. It is in a pellet form and its molecular weight is 40 grams per mole. The strong alkaline solutions was formed when the sodium hydroxide pellet was dissolved in the solvent such as the water. So in order to prepare 50% and 25% of sodium hydroxide, the mixing ratio between the sodium hydroxide pellet and the distilled water is 250 per 1 and 500 per 1 respectively by weight. So as you can see, we use the sodium hydroxide of 0.1 mole in this study. However, we add 3% of penetrating agent JFC and 2% of sodium sulfide into the solutions. Second picture shows the untreated bamboo fiber that was immersed into the solutions of sodium hydroxide concentrations. The fiber immersion time was 6 hours at the ambient temperature. So the next one, of after the bamboo fiber was treated in the solutions, we need to wash it into the running tap water and rinse with the distilled water. The fiber was immersed into the distilled water for 24 hours to remove any excessive NaO from the fiber. So in order to obtain a pH value of 7, the treated fiber can be neutralized with the acetic acids and then washed with the distilled water again. This washing process was continued until the pH level in the distilled water inside the beaker shows an average of 7 pH value. Finally, the alkali treated bamboo fiber was dried at the ambient temperature. For this research, the fiber analysis will be divided into two tests, which is the physical properties test and the tensile properties test. So for the physical properties evaluations, we will evaluate the diameter and the fineness. For the diameter, we will use the electronic precision micrometer thickness tester according to the ASTM D177. For the fineness, the fiber fineness index was determined as per standards method, which is ASTM D1448. The text value was obtained using the precision digital balance. Next, for the testing and analysis of tensile properties of single fiber, the tensile strength of the fiber was determined under ASTM C155703 standards. The tensile strength test will be performed using the Lloyd instrument universal testing machine using the model of LR30K. This test method will include the tensile strength, elongations, stress and strain, and Young modulus. In this study, it is expected that this research is anticipated a good spinnability potential of treated bamboo fiber towards yarn that will be produced as a result. The second one is the alkaline treatment is predicted to have greater thermal stability and generate a finer treated bamboo fiber. The alkaline treatment is predicted could remove the lightning from the fibers and improve the mechanical properties of the bamboo fiber. And lastly, it is likely to result a decline pattern of result diameter and cross-sectional area after fiber being treated with the alkali. It means that this decline pattern was corresponding with the increasing of concentrations of alkaline treatment. Therefore, this is some of the references that I have been referred in order to write this research study. The other references has been stated in my proposal report. This is the additional slide which shown my research planning of this degree project proposal. I have divided the research planning for 14 weeks. It shows my planning and my work done for the 14 weeks in this semester. That's all for my presentations today, and thank you for your time given to listening to these presentations.